Hey YouTube, morning. So I'm back with you today because I told you guys that I'd be making different types of experiments now to do with energy generation, and uh, I'd said that the next experiment that I was tackling was dye-sensitized solar cells. I'm still going for it. I'm working on different battery techs at the same time, and so I've been experimenting with they call Prussian blue. I find this substance to be extremely interesting because it is what they call electrophotochromic. So what that means is that Prussian blue will reversibly oxidize, and the oxidation process can be reversed with exposure to light. Another thing that's interesting about Prussian blue is it's not just electrophotochromic, it's kind of like hygrochromic, if that's a word, because being exposed to varying moisture levels can cause a similar phenomenon. But anyway, the thing that's neat about Prussian blue is it's a common ingredient in what they call dye-sensitized solar cells. So I came up with this this idea. It's like, okay, well, I want to make a dye-sensitized solar cell, but I don't want to. Yeah, I don't want to spend $50 on like 10 little slides of ITO glass, and like I want to make something nice, or potentially bigger, or like anyway. Definitely, I don't want to spend that much money making these things at home, because if I'm spending $50 on ITO glass, $5 a slide, like what's the point of even doing the home experiment? If I can't even do the home experiment for cheaper than I can buy the professional product, come on. Like, I gotta be able to buy the pieces. I gotta be at least able to buy the pieces for less than what it costs to buy the finished product. So, anyway, I went and I 3D printed up some designs. I came up with this two-piece design because when I tried doing it in one piece, I realized the mess was too much. So, what we have here is my little cell. Now, it's got two pieces. Each piece has a copper wire that's been woven through holes on the side. The bottom has been filled with crushed charcoal that was mixed with water, powdered and mixed with water, and then poured into the bottom and allowed to settle. On top of that, I placed a bunch of pieces of paper towel, which I then saturated with saltwater solution. And then on top of that is this other second piece over here. It's got the copper woven through it. And before I put these two pieces together, I had mixed PVA glue with titanium dioxide and Prussian blue. And so that's what you see on top here, titanium dioxide, PVA glue, Prussian blue mixture. Now, this is supposed to make a dye-sensitized solar cell, from what I can tell. I don't know if I'm being misled or not by ChatGPT when ChatGPT tells me that Prussian blue is a common ingredient in dye-sensitized solar cells. Maybe it is, maybe it's not, I don't know. But, because it's not really my specialty, I'm kind of learning about this as I go. But what's really interesting is the action that it has so far has been kind of more battery-like than solar cell-like. I haven't seen the thing respond to a change in light yet. And I'm wondering, is that because maybe more of the Prussian blue needs to become Prussian white first, and then it'll respond to changes in light? Or maybe the titanium dioxide is too thick. But one way or another, right now I'm getting what to me seems to be galvanic action, or more of like a battery type action out of the cell. Yesterday, when I assembled it and glued it together, it was producing 18 microamps through this little microammeter I have here, and now, as you can see, it's producing 30. And like I said, I haven't seen it respond to changes in light yet. So I'm not 110% sure why. Maybe the titanium dioxide is too thick. That's very much a possibility, because I did see them stressing a lot about how they want like a good uniform and thin layer. So maybe that's the case. One way or another, though, what's interesting is that the current production went from 18 microamps through this meter, all the way up to 30. So I'm curious, because it's done nothing but go up in terms of current production since I assembled it. So I wonder how many days that'll last for and how high it's going to go. I'm going to keep you guys posted, because I find it interesting, and quite honestly, coming up with content is hard. So anyway, if you guys are also interested in seeing how that thing does over time, just come back, and we'll see you then. Bye.